Hello everyone. So I just had a little baby girl. So today I wanted you to work on your lab. So in the post there's a lab report structure, and that goes over the seven sections of a full lab report. Not all the lab reports are going to be full lab reports, but this one is, and the next one is to practice this structure. I'm pretty much going to do this one for you entirely. So in addition to this thing, so you have the title, you have the abstract, the introductions, materials and methods, results, discussion, conclusion, references. I'll let you read those to yourself. I posted a PowerPoint slide in there as well, called Throwing Lab Example Ideas. So you're going to be putting this in your lab notebook. You can copy a lot of it from this PowerPoint slide. It's just notes. You're not making a PowerPoint. But I put the examples for each section in the PowerPoint. So the goal that I'm looking for on these projects is just I want you to sound smart and get used to like presenting your ideas in like a persuasive, well thought out scientific way, right? And you need to be able to convert really crappy data into something that sounds halfway good if need be. Like you need to be able to organize the mess that is your own mind, or the mess that is the experiment, and put it into a good presentation, right? So the title, my idea for the title was Effect of Projectile Mass on Force Generation. You can come up with something like that, but it's like you need to describe it, have any important vocabulary words, whatever, something like that, right? So the abstract, short, concise, try and summarize the experiment. Basically, you're trying to come up with heavy sentences that say a lot without using too many words. So we studied the effects of projectile weight on force generation using slow motion video capture to measure distance versus time plots at various points in the throw. This allowed for the calculation of velocity, acceleration, and force. We found that it's easier to generate more force throwing when using a heavier projectile than projectile down to 0.05 kilograms, something like that, right? So abstract, introduction. We were doing this experiment as an opportunity to practice data collection, organization, and presentation. We were motivated by impassioned speeches by our teacher claiming that this is important to practice, and an inherent desire to understand velocity and force equations using projectile motion. So I didn't edit these. Maybe put them in your words a little bit, but also you can totally just copy what I'm saying on this one. I'm fine with that. Your materials and methods, you can't copy me because I'm not doing this, but this is where you got to draw the experiment. So the like stick figure, throwing, have those distances. This is where you have like, oh yeah, okay, so this is where we get our distance of our throw. This is where we get our T from. This is where we get the distance of the wind up. This is where we get the duration of the wind up, like, right? So all the variables that go in your chart. Draw what you did to save yourself writing time, and then also write what you did well enough that a random person could recreate the experiment. That's what the materials and the method is for. So it's like type of ball you used, the weight of the ball, the no, that's going to be in your, yeah. So you describe like the type of the ball. Yeah, you just describe everything, the materials and the methods. And that whole point is just about replication. So you got to remember and recall and describe what you did so that it can be repeated. And then after that, we go into the results. So this is where your chart goes. If you already have a really nice chart somewhere else in your lab notebook, you can put a section that says see chart on this page, and maybe put like a little post-it note or a sticky note so it's easy to find. If your handwriting is garbage, you can type this all up and glue it in, right? Or I would love for you to practice your handwriting. It helps you think clear to have good handwriting. But the results has the chart. It has all the formulas. So you need to have this section. It has to have the formulas that you use to calculate each part of the chart. So we calculated, we collected distance and time. We used that to calculate velocity. We used velocity to calculate acceleration. We used acceleration to calculate force. So I want an example calculation for each one of those columns on the chart. Like, how did you fill in those columns on the chart? I need to see those example calculations. I need to see those math equations with those numbers plugged into it. And I want to see the equations with no numbers plugged into it. If you want extra credit, find something to do a graph on, or pull something else out of the data that's interesting. So things that are interesting for extra credit would be the comparison of the ratios between the different forces generated and the weights. Like, what's the ratio between the weight and what's the ratio between the forces associated with the weight. So there's all kinds of ways that you could compare those numbers if you want to dig in for extra credit. But that goes in the results section. After that, you have the discussion section. So this is where you interpret and analyze the results and discuss whether the data supports your hypothesis and what the findings mean in the broader context of the experiment's purpose. I didn't do an awesome job on this one with that because the lab wasn't that awesome, but I just said our results matched our intuition / hypothesis that heavier projectiles would allow more force and momentum to be generated during the throw. The difference in force generation between the tennis ball and the baseball was blah, 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 blah. The steel shot followed the same trend. There seems to be a trend where the amount of extra force generated with a heavier projectile diminishes as the weight crosses a certain threshold. It is likely that at some point the projectile would become so heavy that the extra weight would start to result in diminished force output. The object would be too heavy to throw. The discussion is also this: if you want extra credit, what I didn't do here on the discussion is to criticize the experiment. So what went wrong? And when you're in that discussion section and you're trying to criticize the experiment, a lot of people try and blow themselves up, but a true adherent to the scientific method, you go up there and you try and roast yourself harder than anybody else could roast you. So you try and be your own critic of the experiment so that your critics don't have anything else to say. That's the point of discussing the errors and the sources of uncertainty. Because if you are capable of criticizing yourself more than anybody else, that puts you at the head of the intellectual pack. And then conclusion, summarize the findings and the implications of the experiment, and then also what would you like to research in the future. So that's an area where you could have extra credit if you're like, this is what would I want to do if I could make the experiment better, if I could get more funding, like what would I do, what could we do. Like if you want super extra credit and you ever come up with that conclusion, or you come up with an experiment that's like, that would be a cool lab for the class, boom, massive amounts of extra credit. So my conclusion was, we found that the force output when throwing projectiles is closely linked to projectile weight. At lower weights, increased projectile weight allows for more force generation, but at heavier weights, it starts to interfere with the throwing mechanics. In areas of future research, it would be valuable to find what weight threshold starts to negatively impact force generation, and to find out what projectile weight allows for the most force generation and transfer of inertia. And so that's it. So then you can work on that. So really all you need to do for your lab report is to copy most of what I said in the PowerPoint slide over to the appropriate section, draw your experiment in the correct section. So you're drawing your experiment in the materials and the method and describing it. You're putting your chart and your equations and your math in the results section, and then the other sections I pretty much did for you in the PowerPoint. So that just all needs to go in your lab book, and then that's one complete lab report, and that's what I'm looking for in terms of a lab report if I ask us to do a full one. So the next lab is very, very similar, except we've got we've got a rocket going instead of a projectile, so a little bit more fun. The data should be a little bit cleaner. There should be cooler patterns in there to see. And then I want you to, you'll be more or less making a very similar lab report. So on the next one, I want to see how much you guys can do on your own in terms of generating the scientific jargon, using the vocabulary words, like basically like try and demonstrate intelligence, right? Like and share it, make it persuasive. I'm just these lab reports, I want you to think of them as practicing formatting your insights and your epiphanies and your experiences and your intuitions, and formatting them in a rigorous way that makes you that makes your insights believable, persuasive, that other people care about what you think instead of like thinking that you're not smart or whatever. So that's kind of what this is practicing. Alrighty, don't abuse the substitute any more than you would abuse me. Thank you.